everyone, we're given the following system of equations here, and I actually typed this one wrong, so that should be that one. Rx plus Sy equals T, where R, S, and T are integers. For which of the following will there be more than one solution with real number coordinates for the system? So the first thing we're going to do is substitute, and it says y equals x squared. So I'm going to take this equation and write Rx plus Sy. My y is x squared, so I put x squared equals T. Now I'm going to put it in the form of ax squared plus bx plus c equals 0, because these are the discriminants which from the quadratic formula, which help us determine how many solutions we have. So when I put it in this form, I'm going to rearrange this and have sx squared plus rx, subtract the t, and get 0. So what we have is, I'm going to write it again. Let's see, what is this? Starts with s, r, and t. So we have sx squared plus rx minus t equals 0. Now, if it was in the AB form, we usually have a x squared plus bx plus c equals 0, and we want two real roots. More than one solution would be this one. This is what we want. But in our case, we have r, s's, and t's. So if we substitute, this would be r squared minus 4 st has to be greater than 0. So when we plug r's in, this is minus 1t. You're going to have r squared minus 4 st. Rt is going to be negative t, because these are opposite, has to be greater than 0. So when you multiply the two negatives, that means r's is going to be r squared plus 4st is positive. So that if we have a positive under the radical here, this would be r quadratic would be x equals negative r plus or minus square root of r squared minus 4st divided by 2. And then they're just wanting the discriminant, but in terms of r, s, and t. And so the answer in this one would be A. And that's it. Thank you. Have a nice day. Bye-bye.